Welcome to Soul Scientific Production. Allow us to calibrate your mind as you enter your first year of university life. This is going to be truly a great and memorable journey, so hold it with care and purpose. Today, yet another of the wonderful days, we shall discuss measurements and dimensional analysis. Remember to subscribe to this channel as we walk you through chemistry free of charge. Let's proceed to the topics under review. Measurements are very important in everyday life. Any problem-solving process, be it in a hospital, or heavy manufacturing industry, or indeed, a basic process such as driving a car, involves some form of measurement. The following are the topics that follow. Fundamental SI units. Uncertainty in measurements. Reliability of measurements. Types of errors, and finally, significant figures. There are two types of measurements, thus qualitative and quantitative. Qualitative measurements are analysis that involve identification, for example, the metal is copper or the leaf is green. Quantitative measurements deal with how much or how many and a unit of measure, for example, a 10 kilograms bag of sugar, etc. Most scientists use International System of Units or LE System International de Unites, abbreviated SI units. I hope you are proficient in French. The 7 units cannot be derived, so they are called fundamental units or simply base units. Some of the 7 base units are time in seconds, length in meters, amount of substance, measured in moles, to mention but a few. All other units, other than the 7 listed in the table, are called derived units. Typical examples of derived units are, unit of area, which is square meters derived from, length measured in meter, and, speed in meters per second, derived from length and time. Uncertainty in measurement. Measurement always involves estimation or approximation of the last digit. Estimation of the measurement is called uncertainty. For example, the value of 25.4 has an uncertainty digit of 4. This is because the last digit is an estimated value. A volume of 14.17 liters has uncertainty digit of 7. Exact numbers have no uncertainty. These are counting numbers or numbers that come from definitions, e.g. 10 lemons, 1,000 apples, 1,000 liters equals 1 cubic meter, etc. Reliability of measurements. Precision and accuracy describe how reliable a measurement is. Reliability, according to Oxford Learner's Dictionary, defines reliability as the quality of being able to be trusted or dependable. Accuracy is the state of being exact or correct. Scientifically, accuracy is how close the experimental value is to the true value. Precision is how close several experimental values are to one another of the same quantity. There are two types of experimental errors: systematic errors and random errors. Systematic errors are due to identified causes and can, in principle, be managed. Errors of this type result in measured values that are consistently too high or consistently too low. Random errors in experimental measurements are caused by unknown and unpredictable changes in the experiment. These changes may occur in the measuring instruments or in the environmental conditions. To make it clear, random errors are also known as indeterminate errors because their causes are unknown. On the other hand, systematic error are also known as determinate errors because their causes are known. Random errors have equal chance of being high or low. Significant figures means, each of the digits in a number are needed, in order to give it accurately. Rules for significant figures. All integers are always significant, except 0. Exact numbers have an infinite number of significant figures. Leading zeros are not significant, for example, 0.02134, both zeros are not significant. Trailing zeros are only significant if there is a decimal point, for example. 500 has one significant figure. 6.00 times 10 to the power 3 has 3 significant figures. Exponential notation, for example 3.30 times 10 to the power -3, has 3 significant figures. 6 times 10 to the power 7, has 1 significant figure. Captive zero between non-zero integers are always significant. Example, 101, has 3 significant figures. Significant figure operations. Addition and subtraction. The number with the least decimal places dictates the number of decimal places of the result. Example, 32.1 plus 17.43 plus 4.079 equals 53.6. 32.1 has 1 decimal place while the other two have 2 and 3 decimal places respectively. When you add the three numbers, the result is 53.609, which rounds off to 53.6, so the answer will have 1 decimal place. Multiplication and division. The number with the least significant figures determines the number of significant figures of the result. When you compute the number of moles, n, you get 0.177732339, which rounds off to 0.2 moles. Y. The number with the least significant figures is 300, which has 1 significant figure. Therefore, the answer will have 1 significant figure.